Okay, so we have this center of mass point. I'm looking on one face just to describe, because if you do one, they're all actually the same type of summation force. You get to get every single term of these equations. So this was, I believe I have this in the notes. This is a dx. Also importantly, this is the positive direction in x, positive direction in y. So then this half the distance, this is half the distance away. So when it comes to estimating these surface forces, the one thing that we always use is these Taylor expansion, or the first order of a Taylor expansion. So that's just fundamental in all engineering estimations, is you just say that any function at all, I'm going to say, is the function evaluated at a point plus the function derivative evaluated at the point, and then some tiny distance away from x. So this really, if you look at, so if you really look at this, this is really sort of going to be x naught minus x. But since it's so small, since it's such a small value, we're just going to, you can just keep the notation like this, where this is just some small distance away from x. And there are more terms in the Taylor series expansion, but the idea is if this number gets smaller and smaller and smaller and smaller and smaller, as this length is getting smaller, that's what you do. You take these tiny bits of fluid and just go, well, I'm going to consider if it goes really, really, really small. That would mean that all the other terms, since they're like squared terms, would die off, and all that would matter is this. So this is an estimation, you're saying, of what is the force happening on this side. So you just look here, and then you Taylor expand to consider what the force is right there. So the other weird thing about these forces is they have all these components where you have normal forces and then you have shearing forces. So they have these terminologies of sigmas and taus, where sigmas are representative of these forces, right, the compressive forces, and the taus represent, right, the shearing forces, or the forces that are trying to shear that block forward or backward. So we just look at this point and do the Taylor expansion stuff, you would, right, and do that expansion trick stuff. If you orient them like this, and you have these opposite, you will get these expressions where you have normal force evaluated at a point, the derivative, that's a little distance away. Remember, it's divided by 2, just something kind of nice happens there. And then multiply this entire thing by a y, because this is a pressure, which is a force divided by an area. So if you do in 3 dimensions, you would actually multiply it by this, so now you have area, right? So that works out. And that's going to be this one right here. And then for this one right here, this one right here is going to be exact same thing. There's a plus sign on this one because of the coordinate system that you set up. So, and it's also oriented in the correct way. So then if you're looking at just the net forces on these terms, what you do is you would take this one and add this one, so you're going to get this negative relationship, right? So I'll take, right, summation in the x direction of these compressive forces would be this approximation term, which is at a point, go a little forward by delta x divided by 2, look at the derivative of this function, and then add this one, but it's in the wrong way, so then these terms will cancel out, and then I'm minusing the minus, so that becomes a positive, so then these two go away, and you just get this term like that left over. And then there would be other ones too, right? So you'd also going to get these tau, and you have a tau xy. or this tau xy is the one that's represented here, right? So there's no shear right there, but you estimate up to little 4 from that way. And there's even another one that we're not seeing in here because I'm not considering the z part. And your book does it in the 3-dimensional case. And these would be if you're summing up all the surface forces in a certain direction, x, that is what these terms matter. And you're going to have 2 more of these based on like the y projection and then the z projection.